Begin by studying a little bit more in the chemical reaction process formulas. But let's start first with the law of conservation of mass. The law of conservation of mass states that matter cannot be created or destroyed. The amount of matter in the universe is always constant. That same law states that not only can matter never be created or destroyed, we have the same amount of matter in the universe that we've always had. Now, that law still applies to a chemical reaction. The amount of matter that we begin with in a chemical reaction has to equal the amount of matter that comes out of the chemical reaction. So let's start right here with vinegar and baking soda. We did that earlier on this week, and we saw that there was a chemical reaction. It produced a heavy gas. So the formula for vinegar is CH3COOH plus baking soda, sodium, hydrogen, carbon, oxygen 3. Some of my more observant students noticed that we had to write the molecule differently than what we should have traditionally learned, where we could have done a C2H4O2, but that actually is ketene hydrate. So we write vinegar that way because it is a longer molecule of carbon, hydrogen, and oxygens. And so because it's unique, the molecule is determined by writing it that way. So once we added those two together, the product turned out to be sodium acetate, water, and carbon dioxide. And there are the formulas: CH3COO Na, then water, H2O, and then carbon dioxide, CO2. That was the gas that was formed from this chemical reaction. One of the things we're going to learn in 6th grade is that we have different elements in this. We have carbon, hydrogen, oxygen. So we'll write carbon, hydrogen, and oxygen. We also have sodium. Sodium. That should cover all of them. This is for 6th grade only. So now coming over here, we have carbon, hydrogen, carbon, hydrogen, carbon, oxygen, oxygen, and sodium. There's a carbon again, oxygen, sodium. We have H2O. So we have hydrogen, 2O, and oxygen. And we have CO2. That's part of the carbon and the oxygen. There cannot be any elements added to or taken away from the reactants or the products. They have to remain the same. But for a little bit more in depth, what I like to show the students is that the number of atoms of each have to equal each other. And that is the true law of conservation of mass. So if we have one carbon here, we got to take off one carbon there. If we have 3 hydrogens here, we have to take off 3 hydrogens here. We'll do carbon, oxygen, oxygen. Go over here, carbon, oxygen, oxygen. Let's find the hydrogen over here. And we have 1 hydrogen there. We're going to take the sodium. We're going to take off the sodium there. The hydrogen. That is the second hydrogen right there because we have 2 atoms of hydrogen. So we can mark that off now. We have carbon, carbon, and we have O3. This is important to realize. If you look at the oxygen of the water, there's 1. And on the carbon dioxide, we have 2. So that's 2 and 3. And if you look now, you will see that they've all canceled each other out. And matter was not created or destroyed. And this is a balanced formula. Hope you enjoy and keep up the hard work.